This is lesson 02, real numbers. So it's the beginning of our algebra class, and it's basically prerequisite material to get us ready for Algebra 1. So we're starting off by reviewing the universal set of all real numbers. In the universal set of all real numbers, you have rational numbers, which is the most commonly used and the ones you should be most familiar with. And then there's irrational numbers that you have been introduced to in the last few years, couple years. Rational numbers are defined by any number that can be written as a fraction. So what I want to show you is that in the set of rational numbers, you have all of these sets, okay? There are, of course, just regular plain old fractions, okay? The plain old fractions would be out here, just like that. You have repeating decimals that you can make a fraction, and we'll talk about that in just a second, see if anybody remembers how you make that a fraction. And then mixed numbers, that you do that little procedure, 5 times 2 plus 1, 11/5, okay? So that becomes a fraction. But inside the rational set, there are these subsets. The biggest one is the set of integers. That means all positive and negative numbers that don't have any decimals or fractions with them. How do you make an integer a fraction? How would I make that -7 a fraction? What could I do with it, AJ?
Put 1 over -7.
Not 1 over -7. Try again.
1 over 7.
Nope. One more time. Don't put the 1 on top. No, you got to do -7. Who else wants to try? Lauren? -7 over 1. -7 over 1 makes it a fraction. So if you get an integer, you make it a fraction by putting the 1 on the bottom. All right? Within the set of integers, you have the set of whole numbers. And basically, that's almost half. It's all of the positive integers plus 0. Then finally, the smallest set is, they're called natural. When you were younger, they were called counting numbers because basically they're all the whole numbers except 0. So they start with 1, natural, it's the numbers you count with. And you make those fractions all the same way. So all of the ones in the circle, you would make them a fraction by putting them over 1. The irrational numbers are the numbers that you can't make a fraction. They are decimals that never stop, and they don't repeat the same digits where you could put a repeating bar over it. The most common, or most famous, I meant to say, most famous irrational is pi. We even had a Pi Day contest about that. Irrational is usually introduced when you start talking about square roots, because when you square root, a lot of time you don't get a whole number of any kind. It just becomes this old long decimal. And then I just threw this in there to show you if you're given a decimal of some sort and they don't repeat where you put a bar and ... that just means it's going on forever. That's irrational. So as we look at this a little further, I've got some examples of numbers that are rational. So just plain fractions, 4/5, -1/8, then plain decimals, because you would say this as 5/10. Well, that's a fraction. Mixed numbers, we already talked about that. Whole numbers of any sort or integers, and then repeating decimals. So let's talk about this repeating decimal, 0.7 repeating. Can anybody in here remember what that trick was I told you about changing that to a fraction? Rebecca? Put it over 9. Yeah. Well, when you guys are in pre-algebra, I just said, hey, just trust me. There's a way to do this. You just put it over 9. Well, so that would be, oops, I don't want to write with that. That would be 7/9. Okay, well, now here's the deal. You guys are in Algebra 1. So I'm going to show you how that happens. It happens like this. You see where I say there, let 0.7 repeating equal n? I'm going to do this. I'm going to take both sides times 10. And what I would have, and I'm going to kind of switch it around here. I'm going to have, what do you think n times 10 is going to be? 10n equals, what about 0.7 repeating? What happens when you multiply a decimal by 10? What happens to that decimal? Anybody know? Where does it go when you multiply by 10? What? 1 point over. So it becomes 7.777, and since it's repeating, you know, it just keeps going. So that's by taking the equation, both sides times 10, that's legal as long as you do the same thing to both sides. Well, I'm going to write below it the original thing, which was n equals, and that was 0.7 repeating. Something that you didn't know about, that you will work on this in the future. You can take equations and add them and subtract them, and you still have the same equal equation. So right now we are going to subtract the bottom equation from the top. What would 10n minus n be? What's really in front of that n on the bottom? What number? 1. So what's 10n minus 1n? 9n. And then this 7 point, all those 7s, minus point all those 7s, look what's going to happen, and this is going to be 7. How do you solve an equation that looks like that? 9 times n equals 7. What was always our last step in solving an equation? What's always the last step in solving an equation like that? Charlie? Divide by 9. And 9 divided by 9 on the left goes away, and look what happens. Didn't we get what I told you we'd get? That's how it's really done. Back when you guys were in pre-algebra, I just told you because I thought this was a little complicated, but the further you get on in math, it will make a lot of sense, and you'll be able to do it on your own if you would have to show it. For us, I'm still happy with you remembering there's a 9 there and just put the 9. If it would be 2 digits repeating, it'd be over not just 9, but 99. And if it was 3 digits repeating, it'd be over 999. Okay, so that key is that there's a 9 there. All right, so the next part just gives you examples of each type of numbers that we had in that box. There's the set of integers, there's the set of whole numbers, natural, we've already talked about, and what irrational numbers are. You will probably have to put in, they'll give you some numbers, and you'll have to decide which set or sets they're in. So just remember, you kind of go up this list over here on the left. If you had a natural number, let's say they give you the number 3 and ask you what sets it belongs to. If they gave you 3, you'd have to say natural, whole, integer, rational. It's in all of them. If they gave you a -1, well, a -1 is an integer, but it's also in rational. All right, and then just because a number's rational, like 2/3, doesn't mean it's in natural or whole or anything like that. But from this list, you go from the bottom up. If it's natural, then it would be those others. So you might have to say which ones they have, like the whole list of them. Irrational numbers never become any of those other ones. They're just plain old irrational. If you have to do a square root to make sure that a number is irrational, you can do that. Pretty much, if it's not a perfect square in that radical sign, it's not rational. Can somebody give me an example of what a perfect square is? What am I talking about? when you square root something? What would be a perfect square? Give me an example of one, Emily. 4. Because when I square root 4, it's asking what number times itself gave me 4. So what would that be? 2. Okay, so you see what I'm saying with perfect squares? That's fine, but other numbers that are in radicals, those are probably going to be irrational. Questions about anything I just said? All right, so you're going to have to identify sets of numbers. There's some examples there. We're going to talk about this graphing. This was something that we did last year, 8th grade year, estimating where you graph those points. So negative 4/5, can somebody just give me a guesstimate where that negative 4/5 is going to go between what two numbers? Between what two numbers on my graph would I go with negative 4/5? Emily? What? Yep, it would go here, so 4/5 of the way. So it would go about right here. I'm going to go ahead and put this up above it. Okay, what about if we had to do one, I think that is 1/2, right? 1/2, where's 1/2 going to go? Between what two numbers? Jennifer? 0 and 1, and right smack dab in the middle. Okay, now here's one that might be a little different for some of you. Radical 8. Is 8 a perfect square? No. What's the closest perfect square that it could get to? 9. That's okay. 9. So what is the square root of 9? What's the square root of 9, Rebecca? 3. So what do you think about square root of 8? Isn't it going to be smaller than 3? So I don't know exactly where it goes because I'm not going to use a calculator on this. I would just put it just almost to 3 and put radical 8, and I would be right. Is there questions about that radical 8? The fraction ones you should know pretty well. The radical ones you would have to kind of estimate based on what perfect squares you know, which we're going to talk a lot more about that right now. Questions? All right, so squares and square roots. The list on the left is squares. The list on the right is square roots. So 1 squared is 1, because you take 1 times 1 to get it. 2 squared is 4, 2 times 2. 3 squared is 9, 3 times 3. But on the right, if you take the square root of those perfect squares, you get back to that original integer. So if I did the next one, I'd say 4 squared is how much? Anybody? 16. And then the square root of 16 is 4. This list right here, you're going to need to make a little bit longer for yourselves, because with what we're doing the next today, and when we do a little test or quiz over it, you're not supposed to use a calculator. So you just simply make your list longer by multiplying those numbers by itself. What would be the next number in our list after 16? 25. If you are asked to evaluate these square roots, you go by what symbol is in front of the radical sign. Like this one is radical 16, well then there's no symbol, you would just say 4. If it says the negative of square root of 16, you would say negative 4. If it says plus or minus square root of 16, you must say plus or minus 4. A couple of other things, if there is a negative on the inside, for us right now, that is not possible. That changes in Algebra 2, so be thankful for it now. We can't do that one. If it would be a decimal, then it would have a decimal answer. And if it would be something fractional, like 16 over 49, you would separate it, because they're both perfect squares, and then reduce each of those.